Hello everyone, my name is Raina D. Jute, and welcome to my Module 11 technical demo and code overview. So I built this Spring Boot application for Rocket Food Delivery. It's basically a back office admin panel where staff can manage customers, restaurants, orders, that kind of thing. Now, I'm coming from React and Node.js, right? So when I first started this, I was expecting to build an API that returns JSON and then React would do all the rendering. But that's not what's happening here. This application renders HTML on the server, not on the client. So there's no React, no fancy JavaScript in the browser, just regular HTML forms. The server does all the thinking, the browser just displays what it gets back. So let me show you what this looks like. So this is the main project structure of this project. And as you can see, there's a lot of folders, and these folders represent the different layers of the application. And I'm still kind of getting used to it, but I think of it sort of like a relay race. So when a request comes in and it gets passed down through these layers, the controller hands it off to service hands it off to repository, and repository talks to the database. Then on the way back, everything flows back up to the browser. So each layer has one job. That's the idea anyway. So let me explain what that actually means. So there are a few foundational things that I had to wrap my head around. Let's break down everything because they kind of explain everything else. So first, what even is Spring Boot? Think of it like Express, the Node.js framework, but Express is like you get a blank canvas and you have to set everything up yourself. Database connection, authentication, templates, error handling, all of that is you. Spring Boot comes in with all of that already built in. It's like buying a house versus renting a blank lot. The plumbing's there, the walls are there, you can just move in and decorate. So I spend less time on the boilerplate of this project and more time on the actual business logic. So second is this MVC model that we've seen in the past. This is a pattern for organizing code, and honestly, it's a little bit simpler than I expected. So the modal is like your data, like the actual objects and database stuff. View is what the user sees, so it's the HTML templates. And controller is like the traffic cop. It receives a request, says, hey, modal, give me some data, and then tells the view, render this. So when someone goes to back office/customers, the controller intercepts that, calls the modal for the customer list, and tells the view to render an HTML page with that data. That's it. So controller, modal, view. It's like a relay race, like I said. Third is the Spring Security, the bouncer of the entire application. So Spring Security's job is to stand at the door and ask, are you logged in? Do you have permission to be here? In this app, if you try to go to back office/anything without logging in, Spring Security just redirects you to the login page, no questions asked. And it does this using sessions, not JWT tokens like in the Node.js world. So when you log in, the server creates a session and stores a cookie in your browser. Every request you make includes that cookie, so the server knows it's you. It's honestly less to think about than tokens. The cookie just kind of shows up, the server knows who you are, and then done. And this was a little bit hard to grasp coming from a MERN stack development because I'm used to authentication middleware and tokens and session-based IDs and all of these things. I'm used to having to put that into my project and route all of the requests through it, but turns out Spring Boot has it already built in. So it was confusing to figure out, but then once I figured it out, it wasn't confusing at all. So now let's talk about how a request goes through all of these layers. Because it's one thing to say controller calls, service calls, repository. It's another thing to see it actually happen. So let's say a user goes to the localhost/back office/customers and hits enter. First thing that happens, the browser sends an HTTP GET request. It just says, get me the customer list. That's it. Step 2 is then Spring Security checks if you're allowed. So the request hits Spring Security first. Spring Security asks, is this person logged in? Have they got a valid session cookie? If yes, then the request continues. If no, then it directs us to login. This is the bouncer doing its job. And we can see this happening inside of our code at securityconfig.java. This block right here, this is basically Spring Security saying any URL that matches back office/whatever, those requests need to be authenticated. Everything else is fine, do whatever. So the bouncer's rules are written right here. And then step 3 is the request hits the controller. So now that we're past security, the request hits the customer controller. So let me show you that. So what's actually happening here? The @getMapping annotation is basically Spring saying, when someone sends a GET request to this URL, run this method. Then the method does 3 things. So 1, it calls this customer service find all. So it's asking the service layer, hey, go get me all the customers. 2, it takes all of those customers and adds them to this thing called a modal or a model. I'm still not sure exactly what it's called. So think of a model like a package of data. So here's your data. Now here's this package you're going to deliver to the view. 3, it returns the name of the template, customer/customer list. It's telling Spring, go render this HTML template with the data in the modal. That's the controller's whole job. It's the traffic cop. It says where to go, what data to grab, and what to render. Then step step 4 is the service does all the work. So the controller asks for customers. The service layer is where the work happens. So let me show you that. So here is customer service.java, and this entire section right up here is what's doing the work when we find all the customers. The service is where you put all the validation, business logic, all that stuff. But in this case, it's pretty straightforward. It just calls the repository. So you'll notice something though, that the repository is injected in the constructor. The service says, I need a customer repository to work. Someone needs to give me one. And Spring automatically provides it. This is called dependency injection. And it's honestly one of the smartest things that Spring does. So the service doesn't create the repository itself. Spring creates it and then hands it over. This makes testing easier and makes the code more flexible. And then step 5 is the repository talks to our database. Now the service calls customer repository find all. The repository is where we actually touch the database. So if I open up customer repository.java, here's the repository interface. Okay, so this part was wild. The repository is literally just an interface. So we don't write the implementation, we extend JPA repository, and Spring automatically gives us methods like find all, save, and delete by ID. So when we call find all, Spring Data, JPA, and Hibernate translate that into an actual SQL query, which is select from customers. We never write SQL, the framework just kind of does it for us. I still think this is kind of magic, but in a good way. And then step 6 is data flows back up. So then Thymeleaf renders the HTML. The database returns rows. These flow back up, repository, service, controller. The controller puts them into the model, and then the model goes to Thymeleaf, which is the template engine. Thymeleaf's job is to take the data in the modal and then render it into actual data. So if we take a look at the customer list.html, so this is our template for this page. This is just a regular HTML table, but notice these th that we'll see all over the place. So we've got this th if, th text, and so on and so forth. This is Thymeleaf. It says I have a list called customers in model, loop through each one and render a table row. So if there are 3 customers in the list, Thymeleaf generates 3 rows. Each row gets the actual ID and the phone number filled in. This is what React does on the client, but Thymeleaf does it on the server-side rendering. I still don't fully understand it, but then Thymeleaf finishes rendering, it sends back the complete finished HTML back to the browser, then the browser displays it. So if I log in here real quickly and I take a look at customers, this is our customer list table. This is the request that we just walked through. So now let's talk about create. So now that we understand how reading data works, but what about actually creating something? Like if someone clicks create a customer. So let me show you the code for that because it's a little bit more involved. So there are 2 methods here, and as we can see right here on the screen, let's walk through what happens when someone clicks create. So first they click a button that sends a get request to the /backoffice/customers/new. Then the get mapping new method runs. What does it do? It creates a new empty customer object. It adds it to the model, and then it returns the name of the form template. So the browser sees a blank form. Then the user fills in the form. They type in a phone number, they type in an address, and then they click submit. Now it's a post request to back office customers, as we can see right here. The second method, the post mapping, then runs. This is where it gets interesting. So Spring automatically binds form data to the customer object. So all the fields from the form get mapped to customer. That's what model attribute does right here. Then there's this @valid, which tells Spring validate this customer object before I get to use it. If the customer doesn't pass validation, if required fields are missing, or whatever the case is, the binding result captures those errors. If there are errors, it just re-renders the form with error messages and the user sees what went wrong. But if validation passes, the method calls customer service create customer. Then service saves it to the database, and then it adds a flash message and redirects back to the customer list. The flash message is like a one-time notification. You get redirected to the list page, and at the top you see customer created. The message disappears on the next request. All of that happens in like 50 milliseconds. The user clicks submit, and suddenly they're back on the list seeing their new customer, so it feels instant. And if I show you the actual form template, so the form uses this th object customer to bind to the customer object from the model. So when you type in the phone field, it's binding to customer phone. Then this th field attribute is Thymeleaf's way of saying this input is tied to this field on the object. So the form knows exactly where the data is going. And then we see this line, if field has errors, That's error handling. So if the phone field fails validation, Thymeleaf shows the error message right there. That's how the user knows what went wrong. So this is all handled on the server. There's no JavaScript validation. There's just the required attribute for basic HTML validation, but the real validation happens when the form posts. So let me actually show you how this is working. I'm going to start the server and walk through creating a customer in real time. So in order to start the server, I type in my terminal mvnw spring boot run. So the application is starting right now. Spring Boot is doing a bunch of stuff, starting the embedded Tomcat server, connecting to MySQL, scanning for entity classes, registering all of the controllers and services. And then we see database seeding complete and that the live reload server is running on port 8080. So now that it's running, let's take a look at the actual application in the browser. So this is the customer list page. This HTML was generated by Thymeleaf on the server using that th:"each" loop we saw. So it's looping through all of the customers in the database and then rendering a row for each one. So each customer has an edit button and a delete button. It's a pretty simple UI, not necessarily what I'm used to, but this was an overwhelming project and I didn't have time to make it look nice. So it's functional, that's all that matters. So let me click on new customer. So when I click on that new customer button, the clicking on the button sends the GET request to backoffice/customer/new. The controllers show create form method runs and then returns this form template. And here's the empty form. So this is called customerform.html. It's blank because we just created an empty customer object and passed it to the template. So let's fill this out. When I click save, it sends a post request with all of this form data. So behind the scenes, this is what's happening. So Spring binds the form data to the customer object. The @valid annotation triggers a validation. The service's save method is called. The repository saves the customer to the database. The controller redirects back to the list, and then the whole thing takes only a couple of milliseconds. And as you can see, our new customer is right there on the screen instantly, and we're back on the customer list. And you can see at the top, there's that customer created successfully message. That's the flash message that we saw in the code. So it'll disappear on the next request. And if I look at the table, there's our new customer. With the phone number we just entered, it came from a fresh query to the database, and that's why it's there immediately. So that's a complete create operation. We saw the code, architecture, and the actual browser behavior all fit together. So now let's move on to the mental shift of this project. So to be honest, coming from React and Node.js, this feels very backwards at first. So in a MERN stack, you build an API that returns JSON. React gets that JSON and it decides how to render it. In Spring Boot MVC, the server returns complete HTML. There's no decide how to render it because rendering already happened on the server. At first, I was like, where's the API? How is this happening? Where is the interactive stuff? And the answer is this is a back office admin panel. It doesn't need to be a complex interactive UI. It needs to be simple, fast, easy to maintain, and functionally manage data. And actually, it delivers on that. So you click a button, the page updates. There's no delay. The architecture is simpler. There's no API contract to maintain between the front end and the back end because it's all actually just back end. So it's not backwards, it's just different. And for this use case, it is the right choice. So here's where I'm at with this. What I actually understand now is MVC is surprisingly simple. You've got a controller that says, what do I do with this request? A service that does the actual work, a repository that talks to the database, data flows down, gets processed, flows back up, and then gets rendered by Thymeleaf. Spring's annotations are just configuration. So @controller says this is a controller. @getMapping says this method handles GET requests. Then form binding is elegant. So Thymeleaf automatically maps form fields to Java objects. You don't have to really manually parse anything. Spring handles the boring stuff, dependency injection, database pooling, transaction management. I don't have to think about it, it's just there, and I just have to write the business logic behind it. And Thymeleaf is simpler than React in a couple of ways for server-rendered apps. So there's no state management libraries, no complex component life cycles. We just loop through data, render the HTML, and then send it to the browser. There's definitely stuff I'm still wrapping my head around, like entity relationships are confusing. The many-to-one, one-to-one, lazy loading. When a customer loads, sometimes it's the user, sometimes it loads the user, sometimes it doesn't. the actual project works, but the mechanics are still kind of fuzzy. And with transaction management, when to use @transactional, what happens if something fails, mid-transaction, cascade delete rules, there's a lot of subtlety here. And Spring Security just feels magical. The security filter chain just intercepts requests. It works, but I don't really understand exactly when and how it's doing that. And debugging Thymeleaf errors, the stack traces are dense, so I'm slowly learning to read them, but it's not necessarily intuitive yet. But I'm getting there. It's not harder than React, it's just different, and once I accepted the pattern, it actually moves pretty fast. So not a terribly detailed technical demo and overview. There's still a lot I don't necessarily understand, but I get the gist of. So thank you for watching, and I will see you on the next one.